Hi, Stuart. Welcome back.
Thank you, Adam. Good to be back again.
Yeah, and apologies for for my Twitter announcement just mentioning Stuart Marks, but of course I also have to use the Dr. Deprecator handle as well.
Okay, yeah, not a problem, but we'll make sure to keep that covered in the future.
This reminds me, like Marvel superheroes. Like there are also two personalities, like Stuart Marks and Dr. Deprecator. It really depends in which mode you are operating, right? Removing that code or just talking at podcast with me.
Yeah, that's right. People say, I've never seen Dr. Deprecator and Stuart Marks in the same room at the same time.
That's great. So before we cover your JDK group, how to call it, endeavors, I would like to know, what was your father's computer?
Yeah, so when we started the previous time, I talked about the Wang 2200, which was my first computer, which my father brought home from his job on weekends. So that's how I learned to program. But I think it's also an interesting bit of computer history to talk about how he got his start in computer programming. And so in the 1950s, he worked as a shipping clerk for the Western Pacific Railroad. And so at that time, so Western Pacific was, I don't know that much about it, but it was a big railroad operation. They moved a lot of freight around the country. And the way they kept track of things was on paper. And so if somebody wanted to ship something, they would submit an order, and then there was a staff of people who would take all the orders, and they would keep track of where all the train cars were and which trains were going in which direction at which time. And they had to match up the trains with the cargo that was to be put on them and try to give an estimate of when the cargo would arrive. And also, of course, they would want to optimize things. So you think about this a little bit. This is a classic optimization problem. And it's also something that is easily amenable to being put onto a computer. But in the 1950s, businesses like railroads didn't have computers. But there was this company called IBM that was in the business of selling computers. And so they contacted Western Pacific and said, hey, you can do a better job optimizing all of your route planning and whatnot if you had one of our computers. So Western Pacific bought some computers from IBM, but computers need people to program them, and so there was no career of computer programmers. The industry just didn't exist. This was extremely early in the industry. And so IBM realized this. So as part of their offering, instead of just selling the computer, they said, okay, we also have training programs so you can train your staff how to program and operate the computer. And so what they did was they put a whole bunch of employees through an aptitude test and to see how well suited they were to doing computer programming. And so at the time, my dad, I guess he was just pushing paper around as a shipping clerk. He took this test, and somewhere in my archives, I have his test results from IBM, which were, to Joseph R. Marks. Dear Mr. Marks, here is your score on the IBM Computer Programming Aptitude Test. And it had a bunch of numbers and stuff. And it says, this score places you in the 99th percentile of all people who have taken the test, which shows that you are eminently suited to become a computer programmer. And so that is how my father got his start in computing. So at that point, they stopped tracking all the train cargo on paper, and he moved into the computer programming shop. And so I believe his first computer was an IBM 1401, which is what was contemporary at the time. That was about 1960 or so. So that he had a couple jobs programming the 1401 before he moved to Wang Laboratories, which is where I ended up when I was talking about this in the previous podcast.
But your father worked for the Wang Laboratories or used the computer?
Well, so this was before he joined Wang.
Ah, okay.
So this was at Western Pacific. Inside of Western Pacific, they gave this aptitude test to a bunch of.
This is what I understood, but I later I just I just thought that your dad used Wang computers, but he actually worked for Wang. So this was interesting. Mm-hmm.
Oh yes. I don't know if that was clear. Yeah. So he had several jobs after Western Pacific, and he did eventually end up working for Wang Laboratories.
Okay. I took a look at the computer Wikipedia. There was a picture, and I read about that. So it's actually an interesting story, and the computer also looked interesting, and it had some what was it? It was one of the only computers with built-in tape, I think, right? Because there was something special. So they compare it with HP. Forgot about this. But immediately after our talk, I just looked at the Wang, and there was a picture, and Wikipedia describes it quite well. I actually put this to the show notes, the description of the Wang computer.
Yeah. Mm-hmm. Saw that.
So interesting. So, but was your dad's computer the IBM, or he used the computer? So was it possible in 1960s to have a computer, to buy one, or?
Well, so no, the IBM 1401 was, I guess it's hard to say. You might call it a mini computer.
Mm-hmm.
Or I don't know. It was before this distinction of mini computers and mainframes. But basically, no. This is something that was far too expensive for an individual to own.
Yeah, this is what I suspected.
Yeah, an IBM 1401 was something that fit in a machine room, and there was a cabinet for the CPU. Mm-hmm. There was a cabinet for the memory. The printer was as large as a washing machine. The card punch was the same size. A card reader was the same size. They also had a tape drive that was the size of a refrigerator. So this is something you need a dedicated machine room for.
Yeah. And actually, really interesting story, because fascinating, right? So how the companies moved from paper, which now is really hard to imagine, without a database. The paper is a database, and
right.
And then to computers. And what interests me very briefly, what was the transition between from Western Pacific, you said, to Wang? So how your father got to Wang? So this also could be also interesting. So
well, I actually don't know that much. So at Western Pacific, they were users of computers, and so he programmed the computer to run applications that Western Pacific needed to do their route planning and whatnot. He had I don't know. This was actually before I was born, so I don't know. And sure. He talked about it a little bit, but I just don't know the details of when and why he switched jobs. I think the reason he ended up with Wang Laboratories is that he really was interested in computer programming.
Okay.
And so instead, he had a couple of previous, the Western Pacific job and a couple of other jobs he had were programming applications for companies that used computers. Mm-hmm. And I think what was interesting was at Wang Laboratories, they produced the computers, so he was much closer to the development of them. That's, so, and then Wang was doing, they were doing a lot of interesting work. Mm-hmm. Even before the Wang 2200, they had some programmable desktop calculators. Mm-hmm. And so he did a lot of programming on those. And those were interesting. And in fact, those were like the 2200. The earlier models were portable. You could, there was several boxes and a couple cables, but you could disconnect them and wrap up the cables and carry a few boxes and put them in your car. And so mm-hmm. that was, they didn't call them personal computing at that point, but it really was. You could pick it up, carry it somewhere, plug it in, and do some work on it.
Mm-hmm. The last time we stopped, with your transition to the JDK group at Oracle. So, what you did the first days, at JDK group? So, how such a transition looks like? Was it just, signing papers, or what happened?
Well, you mean between Sun and Oracle, or switching group?
Both, right? Well, both is interesting. So.
Yeah. Well, I don't know. The corporate acquisition stuff, they were actually separate. But I was working on Java FX at the time. We talked about that a little bit the last time. But when the acquisition went through, mm-hmm. There was a bunch of paperwork to sign and things like that. And, mm-hmm. Switching email and, just sort of corporate bureaucratic stuff. I had to switch email addresses.
Badges.
Get a new badge, all that kind of stuff. So I mean, Oracle's done a lot of acquisitions. They knew what to do. Say, when new employees come on board, you have to do this and that and the other, and you have to take these online training classes, etc.
Mm-hmm.
One of the nice things about the Oracle acquisition, though, was that the Java, what we call the Java Platform Group, this is the organization that runs Java, delivers the JDK. That group has, for the most part, remained intact since the acquisition.
Mm-hmm.
And obviously people, there have been internal reorganizations, people come and go over time. I mean, it's been 12 years now. But other parts of Sun did not fare as well. I mean, you can talk about the, other prominent projects like Solaris. There was Hudson and Jenkins. That fork was caused by difficulties with the Oracle acquisition, a couple other things.
Mm-hmm.
But anyway, so the Java group, I think, is it's hard to say. I think it's it's been very stable.
Yeah.
Through the acquisition and continuing to the present day.
Mm-hmm. So what was your first, how to call it, task, user story, use case you had to do at the JDK group? So what was your
okay. So what did I do? Actually, so this was in the middle. Okay. So this was 2010. And so this was during the development of JDK 7. So if you remember, the features in JDK 7 were, Project Coin.
Mm-hmm.
It was
small.
It was led by colleague Joe Darcy,
exactly.
who is still around doing a bunch of stuff. But anyway, yeah. So Project Coin was small change in the Java programming language.
Mm-hmm.
So there are a bunch of coin related puns around that. But basically one of my initial tasks was to update the JDK codebase to use the new features.
Mm-hmm.
And it seems it's kind of a small onboarding task, but it actually served, I think it benefited the codebase. Mm-hmm. It was one of the things, there had not been any JDK releases for 5 years between 6 and 7. And so the programming language and the libraries had not changed. I mean, if there was no major release, they really hadn't changed at all during that time. And so if you add new language features and new library APIs, then you really need to go back and make sure that your internal code base is making use of them for a couple of reasons. One is to keep it modern. And, the other is to, it's sort of the eat your own dog food sort of thing, or fly your own airplanes, or however you want to put it. But if you don't put those features to use yourself, then I should state it more positively. If you put those features to use yourself, you will learn new things about them. Mm-hmm. And I think that was one of the major points of this exercise. Right.
Oh.
So there were
you are absolutely right. For you it's obvious, but for me not so, right? Because Java is implemented in Java. I mean, all the libraries. You also you have to use the Java features to implement Java's libraries. So you're absolutely right. Yeah. I never thought about that. So if you're implementing Java and you use more recent features, yeah, of course, then you learn about the features, right? So interesting. Yeah. It's like almost like meta, right? Not almost. It is meta.
Yeah. So I think the language team generally does a very good job at flushing out a bunch of issues. But when you so it's not like putting those features to use found bugs. There are sometimes little rough edges that need to be filed off, so to speak. I think what's more interesting is when you put a language feature to use in real code, you learn a lot of things about the best way to use that feature, kind of style guide sort of issues. Mm-hmm. If you look at the code, if you look at this code, this is a good use of applying this feature here. But in this other case, maybe you shouldn't apply it here because it doesn't help. Mm-hmm. And so there's a lot of experience you can gain and by doing that.
Regarding complete different story regarding style guide, I had a chat with Nikolai Parlok, and there were Sun coding conventions. You remember? There was and they were somehow ported to Oracle, but I would say I don't know whether they are well maintained. Well, Java is really lacking, suggestion how to format code, right? and how to deal, with, because what I'm usually did, I just, read the Sun coding conventions. Okay, then this is my style and just use that. But nowadays, something like this is lacking, right? Like a suggestion, so more a convention, how to format code,
Yeah, there was the original Sun style guide, and there have been a couple attempts to update it over the years, but they've stalled out for one reason or another. Yeah, so there is no unified Java style guide, and I think there's this question of whether can you really have a single style guide for community as broad and diverse and as large as the Java community, or should there be a style guide that, for instance, applies only to OpenJDK code or something like that? I think that's one of the dynamics there. So there's no comprehensive style guide. Of course, other organizations have produced their own Java style guides, and that's fine. So that is kind of a hole. What we have tried to do in a couple cases, in fact, personally, one of the things I did was to produce a style guide for use of the var feature, local variable type inference.
Okay.
I don't know if you've seen that. That's something we did publish, but we put a lot of thought into exactly those issues, which is there's a bunch of documentation and specification about exactly what var is and how it makes its type inference.
Mm-hmm.
But what's missing when you add a new feature is sometimes when should you use it?
Mm-hmm.
And so I can, if you haven't seen that, I can send a link to that.
Yeah, sure.
That was published
would be nice.
years ago. Yeah. So there are some interesting things there. Some people use var all the time. Some people hate it because, they want to see the type there. But I think there's some interesting examples in the style guide where if you say, I'm trying to think of var list equals new array list.
Mm-hmm.
Well, you kind of don't need to see the list type on the left-hand side because it's right there on the right-hand side. So,
yeah, and I actually use var a lot, actually everywhere. And the reason being is at the beginning it was a little bit strange, but if you hover, with the mouse above the variable, you will see the type. So I'm even using Visual Studio Code, which is very simplistic right now. And, with IntelliJ or NetBeans, you get even better support. So not an issue. And what I really like is less code to write. So it looks really concise. So it's actually, it is really nice.
Yeah, one thing about that is that I guess the standard I would apply is use var if a reader of the code without an IDE can figure out what the type is by looking at the right-hand side, or if the reader of the code doesn't actually care what the type is.
Mm-hmm.
And so there's some examples of this in the style guide for var. For instance, if you have a map and you have an entry set, then you want to get an iterator over the entry set in order to delete some items or something like that. You have this type that's a real mouthful, like iterator of map.entry of key comma value or something. It's like you don't care, you're looping over it, right? So calling next and has next. So you really don't. The reader is generally does not actually care what the actual type is. Mm-hmm. And so in that case, I think just use var because, somebody looks at it and says, this is obviously looping over the entries of a map. And that's all they need to know, and they move on.
But there are two use cases of caring, right? If I write a code, for me, it's important to know that the code compiles, so I know what's inside. I like the documentation. And if the code is readable, even if the type is not clear, I actually don't care, right? So I would say if you have a piece of code and you are not sure what the type is, but you completely understand the code, so for me it's good enough because it doesn't have to be perfectly, clear which type is used as long as you can read or understand what's going on.
Exactly. Yeah.
So now back to the style guide, what you started at the beginning, or you said, eat your own dog food with JDK 1.7. Do you remember actually the first features of Project Coin?
Yeah. So one of them was Diamond. So it's like, see, how did that go? So you used to have to say list of string list equals new array list of string.
Mm-hmm.
And so now, with Diamond, I mean, it's really, you just delete whatever's inside the angle bracket, right? So, and that it's kind of interesting. It's interesting in retrospect because one of the criticisms of that at the time was why don't you put type inference on the left hand side instead of on the right hand side? There was some back and forth about that, but I think at the time doing the diamond operator was doable, and it was a limited scope change, and it was a small change, but it also made a nice difference in the code. It did shorten up a fair amount of code.
Yeah.
Now with var, it's like I find myself saying var list equals and then writing out the full type on the right hand side. But still, sometimes I use the diamond operator. It just depends on what the context is. So it's a little odd. We sometimes have type inference going on the left side and sometimes on the right side, but whatever makes the code look more natural. I think there are a bunch of other features. So anyway, that was one that had one of the bigger impacts on code. I think another one of the coin features was try with resources.
Exactly.
And that's probably the most significant of them. And spend a lot of time on that. Certainly the specification is rather more intricate than you might think, but it has to deal with a bunch of cases about where the resource gets closed, and if there's a catch block, and if there's a finally block, and if there's both. So it's actually rather more complicated under the surface than you might think. You can see that if you go to the Java language specification and look at the definition of the try with resources statement. Fundamentally, it's pretty simple. It really is a feature that is nothing more than syntactic sugar. And you can see that in the specification. So if the syntax basically says, writing try parenthesis, resource declaration is equivalent to, and then there's kind of a macro expansion in the spec. Although it's not actually a macro. This happens at compile time. But the interesting thing about it though is, and this is one of these things that came out after several years of usage, which is when should an IDE issue like a warning or an advisory that some variable should be wrapped within try with resources. And it's not always clear because I think the example that asked the question in most serious way was introduced in Java 8 with streams. And so depending on how you open a stream might have a resource in it, in which case you should wrap that stream in try with resources. Or in most cases, like if you're streaming over a list, then there's no resource there, so there's no need to close it. It'll just get garbage collected. And so that I think it was probably IntelliJ. After JDK 7 came out, basically they said anything that was auto-closable needed to be wrapped in try with resources. But then Stream came along, and Stream is auto-closable, but in most cases you don't actually have to close the stream. So there was some adjustment that needed to be made to those warning messages. I think scanner is another example of that, although that's less prominent. You can open a scanner on a file, which will need to be closed. But you can open a scanner over a string and it'll parse out tokens from that string. And so it's like, that's just in memory. So you don't need to close that when it's done.
Yeah, right. This is depends on the underlying source of data, right? Whether it is like in memory or something OS related. So to be clear, what you did back then is, so you refactored already existing JDK code to use the new features, right? This is what you did.
That's right. Yeah.
So which part, do you remember which part you refactored? So where you introduced, the try with resource in JDK?
I don't remember exactly which. One of the things about the JDK code is that it is itself a library. So there are a lot of things that open resources, like the IO package. It opens a resource and then returns it. And so you can't use it with try with resources. So there are those cases. But there are a bunch of other cases. I'm sure there were some in the JDK itself, but I remember going through a lot of test code, and it's very interesting. I think this is an ongoing theme. This is probably not unique to the JDK. The test code is not as robust as the production code. And that contributes, we have some issues with the quality of the test code, with erase failures and things like that. There was a lot of test code where they said, oh, okay, well, open something, use it, and then close it.
Mm-hmm.
At least with our tests, the JDK has its own test framework. And so the test framework, basically you don't need to worry about catching exceptions because the test framework catches all exceptions and then reports an error in the test. And that's a perfectly reasonable thing to do. On the other hand, one JVM will come up and then run a lot of tests.
Mm-hmm.
So we do need to be concerned about resource leaks. And so if there's an error with some resource, then it really should be closed.
Mm-hmm.
So there are a lot of test code that was not doing that. Mm-hmm. So I remember updating a lot of tests to use Travis resources.
And what's the name of the internal testing framework back then? Remember this project name?
Yeah, actually, we still use it. It's called either JTReg or JTReg.
Mm-hmm.
So there's a Java test framework, which is where the JT comes from, and that is primarily used to run the TCK, which
mm-hmm.
is the conformance test suite. And so for the JDK itself, repurposed and augmented the Java test framework in order to turn it into a regression test framework.
Mm-hmm.
And that's what the reg or the reg
regression
part,
okay.
JTReg.
Mm-hmm.
And so that's all open source. There's so JTReg lives in the CodeTools project in OpenJDK, mm-hmm. and the JDK regression test suite is in the JDK itself.
Mm-hmm. So try with resources, the diamond operators. So I remember. So interesting that you said that there were 5 years between JDK 1.6 and JDK 1.7. And what's interesting back then, Java was still getting more and more popular. Just like 5 years, nothing happened, and we got more and more developers. I didn't even notice that there was 5 years. No stagnation, but there was no true innovation, right?
Well, it's interesting. It depends on your point of view. I think to a certain extent there was stagnation. I actually don't know about the number of developers and the size of the community. Maybe it was still growing. Maybe it was maybe that growth was driven by trends in, say, the enterprise space.
Mm-hmm.
Java EE was still going on at that time.
Yeah, this is. Mm-hmm.
But one of the things that I think is a legacy of that gap, I should say the gap was also probably driven by economics, mm-hmm. because in the second half of the 2000s, Sun was losing money and doing layoffs, and teams were shrinking and so forth. Mm-hmm. And so I think I mentioned in the previous podcast that there was a lot of emphasis being placed on the Java FX project mm-hmm. at the time I was working on. But the JDK group was actually sort of starved. Mm-hmm. They were in the JDK group between, say, 2005 and 2010, they were finding it very difficult to make progress. Mm-hmm. I think during that time, people in the industry started to realize that, and they weren't hearing very many things coming out of Sun, and so I think that gave rise to alternative JVM languages. Mm-hmm. I think Scala. Mm-hmm. was created during that time. I think Groovy was created during that time.
Groovy is earlier. So Groovy was even earlier. So Groovy was very early. There was even a JSR for Groovy, I remember. This was one of the first. Oh, yeah, this was crazy. But Groovy was 2003 or something like this. I remember this because... Scala came later, you're right. The problem was lack of functional features like Java 8, right?
Well, certainly that was one thing, the functional style programming that Java 8 enabled, but I think just lack of progress in general, mm-hmm. During that time. If people don't see that if you don't continue to develop a language, then to a certain extent that language is basically dead, mm-hmm. and you get your community drifting away from you. Mm-hmm. And I think that was happening to a certain extent during that time. Mm-hmm. So yeah, I think that gave rise to, I mentioned a couple examples, but maybe there are others besides Scala mm-hmm. that were started during that time, or maybe they got more traction during that time because Java was not evolving to solve problems that people had, and so these alternative platforms were.
Mm-hmm. What I remember, funny fact, with Scala. So Java was told to be that because Scala had back then a native XML support. And everyone wanted to have native XML support in Java. And I thought this is terrible. So I didn't want it to have, XML support at all. And they say, okay, Scala will win because it understands XML natively. I say, okay, this is strange because I didn't want it to do anything with SOAP and XML back then. But this was interesting. This is what I now remembered, that the entire XML discussion with Scala. Do you remember the Scala discussion and XML, Scala in Java?
I don't remember the discussion, but I do remember that at the language level there was tight integration between maybe at the language level, at the syntax level, you could embed XML directly into Scala.
Yeah, exactly.
Very strange. I think they've eventually got rid of that, though, didn't they?
I don't know. I think it was like kind of a builder pattern what they did, right? So how they parsed, or Groovy did this. But Scala there was a huge discussion. This is what I remember. So I tried to ignore that, but it was not always possible. And I completely forgot about the coin name, actually. This is interesting. So I remember this is the predecessor of JEP, I guess, right? Of the JEPs.
Right. Yeah. This JEPs did not exist at the time.
Yeah, exactly.
Yes.
Mm-hmm. Okay. So we discuss now try with resources, diamond operator. Any other JEPs you were involved?
Well, and so this is okay. So I think if I recall correctly, on our previous segment of the podcast, I said that. So I'm in the core libraries team, and so we have about 17 people working on this, and there's still a few areas that we need that we're short staffed on. But at the time, there were 2 people covering all of core libraries, and so it was amazing. Basically, there was so much technical debt and there were so many areas uncovered. And so that was so finally, after the acquisition, we managed to cut through the chaos and figure out how to, I should say the JDK group and the management figured out how to make the case to the new management that, okay, we can bring some more people into the team. So I was brought in along with a couple other people. But one of the other things that I was tasked with was fixing bugs in serialization and RMI. And so, and that was timely. Well, it was not time. I mean, it was driven by need because remember, this is the early 2010s. And so this is like 2011 or so. I mean, it doesn't line up exactly with Java 7. But there were a lot of security vulnerabilities being reported against Java. And the core libraries is very big, and you can easily imagine that you can get into trouble if you get security vulnerabilities reported and there's nobody on staff to deal with them.
Yeah.
So there were some uncomfortable times there. So we actually did hire more people onto core libraries in order to help out with that. And along with other things, we also did staff up a vulnerability team to keeping on top of this stuff. And so that was also a good move. So I work very closely with them. But yeah, so personally, I did fix a lot of vulnerabilities in serialization and RMI. And so you can see that to this day. So I think occasionally I will tweet about that, and I'll tweet some meme that has to do with serialization. I don't know if you've seen those on Twitter. But I've also given conference talks on it because Brian Getz he has a bunch of ideas for a better serialization, I should say. And so, in fact, he wrote a paper called Towards Better Serialization, and he and I gave a talk at Devox a couple of years ago about which is essentially our assessment of why the existing serialization mechanism in Java so many problems.
Yeah, but it already started, right? Because Java records are already serialized differently. So and this is already the first step, I would say, towards better serialization, right?
Yes. Yeah, exactly. It's a first step, but it still really is. It's a modification of the existing serialization framework in Java. And I think eventually we want to have a completely different framework that looks at the world in a different way. And so the record stuff is an important step forward, but still it exists entirely within the existing framework.
Mm-hmm. And can you just briefly explain what would be the major difference between now and future in serialization?
Well, so I think it's so the main issue, and this is mostly Brian Getz's work, but he and I have talked about it extensively. The main issue with the existing serialization mechanism is that it uses, and I'm putting air quotes in here, it uses magic
Mm-hmm.
to get information out of an object and to put information into an object.
Mm-hmm.
And so we did discuss this I'll make sure to post a link to the DevOps talk we gave, because we do talk about this. But basically, if you want to serialize an object, what the serialization mechanism does is it uses reflection to go in and grab all the data from private fields.
Mm-hmm.
And to deserialize an object, it creates an empty object, which is something that you can't do in Java.
Mm-hmm.
The only way to create an object in the Java language is to call a constructor. And the constructor is responsible for taking its arguments and initializing fields and stuff. And what serialization does is it says, no, we're going to use some special mechanism that doesn't exist in the language to create an object with all of its fields empty. And again, it's sort of air quotes. It's like zeros, null, and false. And then it uses reflection to stuff values into the fields. Mm-hmm. And so this is, so this is not unique to Java serialization, but I think other serialization mechanisms try to do this as well. And that's a serious problem because when you're looking at a program, if you write a class, then you can look at the text of your program source and try to reason about it. Mm-hmm. And you can say, so I have this private field here and nobody else can get that. Oh, if it's serializable, that's wrong. Mm-hmm. Or I have some invariants here, which I established in the constructor. But if your object was created via deserialization, then those invariants can be broken. Mm-hmm. And then there's a bunch of special things you have to do, and you pretty much have to stand on your head to get this right. It's almost impossible to get this right to make sure your object is totally safe if it is deserialized, if it has been created via deserialization. Mm-hmm. So it's very, very difficult.
Back then, I even used, to improve performance a bit externalizable. So it was an interface, and it was quite a difference. So it was measurable, the performance difference between serializable and externalizable.
Oh, really? Okay. Mm-hmm. Yeah. So fundamentally, what Brian wants to do, or what we want to do with the whole platform, is make serialization fit well with the language instead of going around the language. And so, if you want to create an object via deserialization, you should create an object just the way everything else creates an object by a constructor, right? There shouldn't be any magic. And if you want to deserialize an object, then instead of reflecting on the fields and grabbing all this private data out and then having some alternative syntax for saying, actually, I don't want you to get this field. I want something else. If you look at the serialization APIs, there are layers of special cases in there. And so this is the area where Project Amber is doing a lot of work these days, which is pattern matching. Mm-hmm. And so one of the things they're working on is pattern matching and extracting. And closely related to that is the idea of a deconstructor.
Destructuring, you mean?
Well, So when you do pattern matching, you can do destructuring and extraction of individual bits of data. But closely related to that is if you want your object to be serializable, how does the serialization framework get its data out of your object? So instead of having the framework reach in and grab things out via reflection, then there would be kind of a special case of a pattern match that says, extract everything. And so basically destruct. Okay. So it's the inverse of a constructor. And so it's not a destructor like in C++. It is a deconstructor. So if you think of, suppose I have a person, which is, name and age, right? There's a string name and int and age, right? And so if I want to serialize that, then, if I have a constructor that takes a string and an int, and then I get a person object out of that. And so a deconstructor is exactly the opposite, which is I want to take a person object and call the deconstructor on that, and it's going to return to me a string and an int.
Mm-hmm.
And so you can sort of see that operating. Well, it doesn't really operate. I mean, so records, I think, are a special case of that, because the idea of records is that every field in a record, or really every component in a record, is visible.
Mm-hmm.
And so there's no encapsulation in a record.
Mm-hmm.
But if you have an object that wants encapsulation, then as the programmer, you're going to need a way to write a deconstruction method
mm-hmm.
that says, return me a bunch of things.
Mm-hmm.
So that's very similar to pattern matching.
With such serialization, Java would even get, it looks to me almost like dependency injection, right? Because you have some state, and if you call the constructor, this is what dependency injection is doing.
Is that right? I'm not that familiar with dependency injection.
Yeah, well, dependency injection, what you're usually doing, you are annotating fields, and reflection is used, and all the fields are set. But you can also annotate the constructor with @inject, and then the dependency injection will call the constructor and set the parameters from outside. And if the serialization uses the same mechanism, it's going to be interesting, because the dependency injection is used for stateless state, right? Because what you are injecting usually is not. This is mostly used, in request response scenarios, where for every request the state is injected, and the state is usually data source or connection pool, which is equal to all requests. It's not like there is a distinction. And serialization and deserialization is more like on entity level. So you could, write your persistence mechanism where you have multiple clients, customers, developers, whatever. But the mechanism is very similar. This is what was interesting. Even more interesting, frameworks like Quarkus, for instance, what they are doing, they are looking at the bytecode, and they are not using reflection. They are generating the bytecode in advance. So at runtime, there is no reflection at all. Everything is already precompiled, or not precompiled, pre-generated. But this is actually interesting, as you said, this with the constructor. So this is will function as dependency injection. Of course, it isn't dependency injection, because dependency, it could be used as dependency injection actually.
Well, yeah, I'm not sure, because I usually think of when I think of dependency injection, I think of you have an object and some data or some resource or something is being injected into the object,
mm-hmm.
and with a deconstructor, the information is being produced by the object.
No, deconstructor, yes, but the constructor invocation during deserialization.
Oh, yes.
This is identical.
Okay. So construction during deserialization. Yes, it is. It is very similar to dependency injection of the flavor where it calls a constructor. Yes. As opposed to there's another flavor of dependency injection that people commonly use, which is to poke things into private fields.
Exactly.
which I think we frown upon in the same way as we do with deserialization. But I think the serialization, then that needs a completely new language construct, which we've referred to as a deconstructor.
Mm-hmm.
And that presses on the language in a whole bunch of different ways, that it hasn't been pressed before. And so one is a simple thing, which is, it's like calling a method, except, it's like calling a method that takes one argument, which is, the receiver, but it needs to return multiple values.
Mm-hmm.
Where do those go?
Stream, and of course, right? Stream of values.
Yeah. Well, no, but they're different. But they're of different types.
Yeah, with pattern matching. This is why we need pattern matching, right?
Well, and so I think pattern matching is, and that's the same issue there, which is, if you do a pattern match, you might selectively match on some of the fields of an object. But again, it's sort of like a multiple value return, which
mm-hmm.
Java doesn't have. And I'm not actually sure how they're going to express that. Whether it's going to be, if you look at the JVM, if you look at the bytecode level, there really is a very strong notion of when something is called, whether it's, whether it's a constructor or whether it's whether it's an ordinary method or a static method, and you can see this all in method handles as well. So through the method handles and bytecodes, there really is a very strong notion of passing in 0 or more arguments. Those arguments have specific types,
Mm-hmm.
and getting 0 or 1 return value.
Mm-hmm.
And so if you want to, quote, return multiple values, how do you do that? Are you going to go through and rewrite all the bytecodes and method handles and stuff to support that? Or I don't think so. Or are you going to wrap it, or are you going to box it all up into some kind of container?
Mm-hmm.
No, I'm not sure what the language guys are thinking about in these terms. Although I have some hints, but I don't know where they're going to go with that.
Back to your serialization and RMI tweets. Actually, one of the tweets I actually responded because you asked. I remember a few years ago, like why RMI is useful, what you're doing with RMI, and my answer was. What we sometimes do is we are just using inter-process communication because it's very easy with RMI. So you can just start a process which was unstable back then. It was with GNI, and if this GNI crashed, our main process still run. So it was really a very convenient way to encapsulate unstable code. And I actually liked RMI a lot. And after Java 5, because you didn't have to generate these stubs and skeletons, you could just use the reflection. So you said, I think naming dot lookup, I think, and you passed an interface and you get this stub back. You got this stub back, and back then you had to use the RMIC compiler to generate these stubs and skeletons. Right. And after the RMIC compiler became optional, then it was actually great times. And but it was a short period in time, and then Corba became very popular, but it was far more complex than RMI, of course. So I never understood why you have to to look up the lookup first in order to look up something else. In the RMI, it was just one method, naming the lookup, which was great.
Yeah.
From the convenience point of view, it was great. Of course, security is different, but from the ergonomics and how it worked with 2 lines of code, you got remote communication.
I think that's right. I mean, that was before I joined the JDK group, but the innovation you're referring to in Java 5 was the use of dynamic proxies.
Exactly.
And so that made it unnecessary to have specific stub classes that were compiled by the RMI compiler. And so I spent my time, a fair amount of time writing RMI test programs and whatnot. And boy, the dynamic stubs really make things easy.
Mm-hmm.
So like you said, all you need is the interface, and you just get me a stub for this from here, and you can make calls on it. So it's very convenient. So I think, so RMI is, I would say, mostly disused at this point.
Mm-hmm.
I mean, in the late 1990s when it was developed, I think there was this idea that people would build these vast distributed applications and, send things across the internet and load classes across the internet, and pretty much everybody has stopped doing that.
Mm-hmm.
But I think there are a few cases of where RMI is useful, which is a tightly coupled set of JVMs running on the same machine.
Yep.
And so if they're tightly coupled, then you can be sure that they have the same class path. So one of the things with distributed systems is that if you're talking to some server that, maybe you don't control, or you don't know if it's been upgraded, it might have a different version of the same class. So how do you detect that? And so there are all these terrible problems that the distributed systems guys had to deal with. And so on a tightly coupled system on the same machine, you can much more easily make security guarantees and correctness guarantees if it's a bunch of JVMs running with the same class path, especially where there's, one JVM started the other. Very convenient to talk to, say, a child process using RMI, because, you just make a few serializable objects and then you can just make calls on it, and it just happens in the sub process.
But this is always back and forth. So what I remember at the beginning with RMI, or a little bit later, so there was criticism, okay, is this very brittle? Because if we change something, the compiler doesn't compile. And also, we always, so what most of the projects did, they set the serial version ID, to be more stable. And then they say, okay, the tolerant reader. This is actually a bad stuff that everything is type safe. Everything has to be not type safe. And then JSON came. So I say, okay, this is great. We have Ruby and we have JavaScript. We write more unit tests, and we don't need type safety. And recently, it was like last year. Someone on Twitter, and Twitter is actually, by the way, terrible right now because with the algorithmic timelines. Sometimes I think someone is talking to me, right? And this is just the timeline, and I'm responding, and this causes some confusion. So I will have to use the Twitter client a little bit more, and in browser it is strange. But someone asked, what are the use cases of TypeScript? And I say, okay, I use just JavaScript. I've used JavaScript because it is enough, and with Visual Studio Code I get the type suggestions, and it's fine. And this was like, I got maybe 100 tweets. Am I crazy? JavaScript is not type safe. You have to understand, TypeScript. This is type safe. For remote communication, you have to use types. It's like, yes, I know, I'm a Java programmer. This was just, if I do JavaScript, I just do JavaScript. And funny stuff is, now in JavaScript world, they do exactly the same now. So they use TypeScript instead of JavaScript. Some projects even generating data transfer objects for the clients and server to be compatible, but they have to do it. They have to generate, otherwise it won't work. So it is exactly what we did 15 years ago in Java. Now we have this exactly the same in TypeScript. I'm just waiting for the moment they say, okay, now it's too brittle, because everything is type safe. Maybe we should introduce JSON again. Or JSON with JSON schema. This was also a short period of time. So, okay, JSON with JSON schema to have the types. And I would say this is always back and forth, and it's a really hard problem. And right now you say RMI is not that popular anymore, but gRPC, Google, gRPC is not Google, but gRPC is a remote protocol. But for me, it looks like Corba. I mean, this is from conceptual perspective. This is exactly the same idea as like Corba. There's IDL, you generate these stubs and skeletons, and it's just popular, and no one remembers Corba anymore, right? This is actually a funny history.
It's all the same thing being reinvented.
Yeah, and the truth is, in some projects, or even in one project, there are some use cases for type-safe communication. There are some use cases for not type-safe communication, and fact is, type-safe communication, if remote communication comes with the problem that the compiler won't compile, which is a great thing. And not type-safe communication means you have to test more. And you are backward compatible, but you have to take your responsibility and write more stable code. But what projects are searching for is like general solution for everything, and this won't work. This is my suspicion.
Yeah.
As a Java user, not a Java implementer.
So let's see, where are we now? We haven't gotten to Java 8 yet, and we haven't gotten to deprecation yet.
No, but this was an interesting story. I would say I have to reinvite you back, right?
Yeah, maybe. I mean, we can go on a little longer if you're okay, but
at least we should actually complete the Coin project. So what we should cover today, at least, is all the features of Coin project which are relevant. So if you remember this would be great, because this was actually the beginning of JEPs, right?
I think in comparison to Diamond and Try with Resources, I think the other Coin features are really not significant.
Mm-hmm.
And I'd have to look them up. I mean, they're pretty obscure.
I think one was it one Coin feature with the number formatting, with the underscores? Was it?
Yeah, you could put underscores in
integers.
In
yeah. This was also
constant.
one feature. This is what I remember. Mm-hmm.
That was nice. And there were some things about exception handling.
Exception handling that the cause.
Well, let's see. So Try with Resources added so the exception cause was added earlier.
Mm-hmm.
One of the side effects.
By the way, which broke serialization in many of my projects, because this was interesting, because the exception got the cause and they were no more serializable. So this was or no more differently serializable.
Yeah.
Mm-hmm.
Yeah. What were there? There were some obscure things. Oh, right. So Try with Resources. A side effect of adding Try with Resources was, in certain cases, Try with Resources would call close for you automatically. But what if close threw an exception? What would happen to that exception? So Try with resources added the notion of suppressed exception.
Mm-hmm.
And so that's yet more exceptions chained off of the top level exception.
Mm-hmm.
And that's a kind of a separate slot in the exception data structure from the exception cause. So you can actually have a tree you can have more than one suppressed exceptions, which means that the entire set of suppressed exceptions is actually a tree, mm-hmm. as opposed to a chain, which is the cause.
Now I found the ultimate resource, Project Coin on OpenJDK. So strings in Switch.
Oh, that's right. Yeah.
So they are significant, actually, right?
Yeah. Yes and no. I mean, it's one of those things that people asked for a lot because it was sort of obviously missing, and the JDK doesn't use it that much. Occasionally, I'll use it in one of my little test programs or something. But I mean, it's nice to have. I mean, mm-hmm. It's not gonna. I don't want to undersell it, but it's not something that fundamentally. To me, it's not something that changed your code fundamentally, same way that try with resources did. In fact, all right, so here's another digression about try with resources.
You actually like the try with resources or hate it? So what's yours now?
I like.
Okay.
But one of the things that connected for me was, all right, so if we fast forward so Java 18 is going to be released tomorrow as we record this, and Java 18 contains JEP 421, which is deprecation for removal of finalization. Mm-hmm. And one of the in working through that, it's amazing, or you study something very closely. My belief is that finalization was necessary in the early days of Java because it was almost impossible to avoid resource leaks using try-catch. Mm-hmm. And we actually have some examples in the JEP. And so we went back and wrote some JDK 1.0 era code. Imagine, I'm sort of imagining it here, which is probably might or might not be a good idea. But basically, suppose you have two files. Suppose you want to copy data from one stream to another, mm-hmm. An input stream to an output stream. You have to open two resources and make sure that you handle exceptions from either of them. And if you get an exception from one, you need to make sure the other is closed.
You know what it is? Two-phase commit. We need a distributed transaction. Yeah. There's exactly the same problem if you would write to two databases, actually, in my enterprise world at the same time.
Sort of. It's in principle, it's actually easier than two-phase commit because you don't need to roll back.
Yeah. But similar problem.
It is a similar problem. But what you need, if you write out all the code to handle the cases properly, where you can get an exception from one thing, from one or the other, and making sure that they're closed in all cases, it's actually really complicated. Mm-hmm. And in fact, with a sufficiently and the evidence of that is try with resources seems like it's pretty simple. It just says, okay, do this try block, but make sure you call close. The system makes sure to call close for you. Well, that goes in a separate finally block that has to go outside the existing try block. Mm-hmm. But try with resources also has to keep track of which resources have been successfully opened, because it doesn't want to call close on the ones that haven't been opened. Mm-hmm. And so if you look at the syntactic sugar expansion of try with resources, it turns out that you actually had to do that by hand in JDK 1.0.
Yeah.
If you were going to write code that correctly avoided resource leaks in the face of some exceptions.
Yeah, and this was actually a pattern back then, how to close a JDBC connection. This was the always huge discussion of how to deal with JDBC connections, because if you close the exception, close the connection, an exception can happen. And
that's right.
And then you have also catch this exception, and what do you do then with the connection? So it was a interesting problem. There was also a huge discussion what to do with it. So the JDBC connection was actually huge. So almost more discussion than XML parser in Scala.
Right. Yeah. So anyway, if you want to do something that is apparently as simple as copying from one file to another and handling all the exceptions and handling the cases where you close both of them, even, if you make sure to close both of them in the normal case, or if you get an exception on one of them, and handle exceptions from calling close on either of them, right? If you write all that out, it's actually like half a page of code. It's ridiculous.
Yeah.
And in practice, nobody did that. And so in practice, people would write code, even if they use this is, remember, back in JDK 1.0, even if they used try-catch finally and attempted to do the right thing, there were probably cases that they still missed. So they would still end up with resource leaks in obscure situations where they got an IO exception on something. And so I'm convinced that's the value of finalization right there, which was all of the JDK classes that represented resources had finalizers. And so eventually, one hopes the garbage collector would run and close any files that you forgot to open because you couldn't be bothered to write the sufficiently complicated exception handling code. Try with resources actually solves that. And we didn't even think about finalization at the time. We were just thinking, gee, there's this problem with file handling, and try with resources solves it.
Anyhow, I was really happy then string in Switch came. So you are not that excited, but for me, it was, it made a difference.
Okay.
Before that, I had to deal with ints, as remember. And with strings are nicer than ints. Then the binary integral literals, underscores in numeric literals. So we talk about that. Multicatch.
Yeah, actually, multicatch was pretty good.
Yeah. And it came with Coin. I thought it came later, but it came with Project Coin, JDK 1.7. I thought it was JDK 1.8, but it was 1.7, so earlier. Diamond, we had it. Try with resources. And varargs. Simplified varargs method invocation.
Oh, yeah, that's really obscure. Varargs was added in Java 5. So the problem with varargs was, let's see, page all this in. Frankly, it's not that interesting, but basically it has to do with if you have a varargs, which is a generic type, varargs is fundamentally about arrays, and arrays and generics don't mix. And so if you had a varargs of a generic type, the compiler would generate a warning that was impossible to avoid. So basically this was a tweak to some of the, basically added an annotation. Basically it was safe varargs.
Yeah.
So basically you could, if you wrote a method that accepted that had a, generic varargs parameter, then you could say, I do not modify this array, therefore heap pollution cannot occur. Therefore, compiler, please do not warn all my callers of potential heap pollution. And basically that's when you write @safe varargs on a method. And that's basically all it is.
Okay. Still see it in code bases, so it's used. And by the way, we missed the window because between February 27th, 2009 through March 30th, 2009, there was you could form actually or file the features, and there were 70 proposals back then. So I'm just on the page from OpenJDK. So we cover now so actually Project Con was significant. So there are some features which are very fresh, and I thought they came later, but they came in 2009. Incredible. So Stuart, or Mr. Deprecator, no, Stuart still, because Mr. Deprecator will come later. But we covered the entire Project Con at least. So we moved a little bit in the Java. Now, we actually moved backwards because the last time we already were in the year 2010, and now we are back to 2009, but still, no.
Yeah. Well, Java 7 was delivered in 2011, so we did move forward a little bit.
1 year. This is perfect.
But we did talk about some. I mean, I think the issues with serialization and RMI are ongoing, and I did spend a lot of time on those in the early part of the 2000s. So we did cover that aspect of it. So we're not going strictly in chronological order.
No problem. What interests me in the new serialization, will it be possible to swap the data formats? Because if your constructor is called, I could choose, to read from whatever. I don't have,
Yes.
Yeah.
So all right. So yeah, returning to that. Yeah, that's. I mean, it's still mostly a set of ideas, but I think it's all in there in Brian Getz's paper. But But one of the other difficulties with Java serialization is that not only does it use this magic to get access to objects, but it also has its own built-in impossible to change data format.
Mm-hmm.
One of the ideas of a new serialization architecture is to decouple those.
Mm-hmm.
And so once you've figured out how to extract data from an object so that you can serialize it, or if you have data to deserialize an object, you figure out which constructor to call, then the format the data is written in is immaterial.
Mm-hmm.
And so, yes, so it should be possible to plug this into some other, some other module that gives you XML or JSON or YAML or whatever you want.
This would be great, actually, because this would kill a lot of frameworks and dependencies. So, because with that, you could just serialize Java to JSON, if Java class to JSON, if you like. This is actually great news. So, I would say there are lots of features in Java which are really exciting. So, destructuring with Java records, this is going to be a big deal, because what you always need, you have a huge Java object, and what you need is a subset and send it somewhere else. So if you have this already with Java record, then you could take a Java record and use the new Java serialization and serialize into JSON. So what it means is the Java programming language becomes more powerful, and we can skip a lot of dependencies, which makes the entire thing more secure and faster and smaller.
Yeah, one hopes. But yeah, actually security is,
security, what I mean by security is, usually serialization involves a lot of external frameworks, dependencies.
Yeah.
And it's not like security for me also means if I don't have, external dependencies, I don't have to care about them, because they can introduce additional problems. So this is what I meant, right?
Well, I think that's a good point. And I certainly don't disagree with that. But I was actually thinking of something else, which is also true about security, which is, and again, we'll make sure to get the link to the talk that Brian and I gave about, why we hate serialization. It's maintainability of code, right? So if you look at code and review it, you need to be able to reason about that code to make sure it's correct. And if your reasoning is flawed, then that's a potential security hole, because somebody can make your object do something that you didn't intend. And then once they have an object that's malformed in some way, then they can use that to harm your system. One of the problems with the existing serialization mechanism is that there's magic going on. And so if you read the code, you think, okay, you can make some assertions about it, but those assertions are false because there's some things going on behind your back. That's the fundamental problem. And so the way that these new ideas about how we could do serialization improve security is that they all go through the programming language. All Java programming is represented in source code. So you should be able to look at the source code and say, aha, when this is deserialized, it goes through this constructor, and I'm going to do these checks that are shared among all the constructors. I know the resulting object will satisfy all its invariants. Very powerful statement to be able to make.
Yeah.
And so I think, just by looking at the source code.
But I still have to say, now it is easy to criticize deserialization, but it is like, JDK 1.1, I think, was introduced, already in 1.0. 1.1, right?
1.1, yeah.
Exactly. And this is actually big deal.
That's one of the things about, as much as we criticize serialization, it was important and necessary, because you do need to have a way to move data from an internal form to an external form and vice versa.
Yeah.
You absolutely need that for distributed systems, to be able to write records with high fidelity to a database or to the file system or anything like that. There's no question that provided value, and it's essential.
Yeah.
Because occasionally somebody comes along and says, why did you just get rid of serialization? It's like, nope. Can't do it. It's too useful and it's too powerful, but it's also very dangerous.
Exactly.
And so we want to preserve things that produce the power, that preserve the power and the usefulness, but make it much less dangerous.
But actually, all power tools are dangerous, right?
I would say I think that's true. Yeah. One of my computer science professors from university said all power tools can kill.
Okay.
It's a different way of saying the same thing. And I think that's true, but some power tools are more dangerous than others, right? You can have a table saw, but you can make a safe table saw by making sure that, you have shielding in the right place and a hand grip. If you put your hands there, you will not get cut.
Yeah.
So I think that's what we need. Safeguards like that.
Thank you. I would like really to re-invite you back, because at least cover JDK 1.8, I would say. This is the great goal, for our next episode. So thank you. It was fun again. And especially I thought a lot to know about the how Western Pacific and with the computer from your dad and Project Coin. Actually, this was a nice memories, because I remembered exactly Java 1 and everything which was Project Coin related, and I forgot the name, Project Coin. And it was a great piece of history. And by the way, and this is also announced bloggers, Joe Darcy and other some bloggers. So this is the community. In CoinDev, there's even a mailing list still announced on OpenJDK. Coin-dev.
CoinDev has been shut down. So that the project is no longer active, but I think all the materials are there for archival purposes.
Mm-hmm. Okay.
But yes, thank you for letting me share the story about my father. I think it's interesting personal history for me, but it's also interesting, I think, computing industry history, because this is how people became programmers in the 1950s. This is what they had to do. And so they created, essentially IBM had a hand in creating the profession of computer programming.
But what really surprised me, how professional such a new industry were back then. That IBM had, like assessment, programmers, and they had the training materials and everything was in place. So this is actually amazing that they were, because if there is a new industry, usually there is no such a thing. If you think right now about machine learning or whatever, or NFTs, right? No one knows what it is. And back then everything was organized and interesting, right?
Well, yes and no, right? So what I have not seen is the aptitude test that they gave him.
This is what I want to ask you.
I would love to see that. And so I think the open question in my mind is whether it actually did correlate with aptitude to be a computer programmer.
Okay.
As my guess is that IBM didn't really know. They probably got a bunch of people into a room and said, what does it take to become a computer programmer? I don't know. Maybe you need to be able to visualize geometric forms in your head or something like that.
Okay.
Maybe that's what they did when they studied math in high school, right? So they wrote some exam questions like that on the exam.
Okay.
So I have no idea what was on the exam. I think that's a whole other topic. I think I should say that, so I don't know if that testing strategy they used was actually successful.
Mm-hmm.
In my father's case, I think it was, because he made a career change based on that, and it served him well for the rest of his career.
Mm-hmm.
So it did work out for my father, but for other people, it might have worked out less well.
Yeah. So, but maybe a listener knows, then they should ping you, and we know with the test. This would be interesting. So, where people can find you on the internet? You have two Twitter handles. We learned the last time, right?
Oh, that's right. Yeah.
One is Stuart Marks, and the other one comes later as Dr. Deprecator.
That's Dr. Deprecator. Yes, that's right.
Perfect. It was fun. I really enjoyed the conversation, and see you next time.
Okay, lots of history again, and still more to come.